Okay, in this video we are going to do more derivatives, okay? Going to take derivatives of more exponential functions, but this time we're going to have polynomials in the picture as well. All right, so try not to get confused which formula we're using. Remember, the idea there, or the key thing there, is to recognize where the variable is. All right, for exponential functions, the variable is in the exponent. For polynomials, the exponent is in the base. Okay, so just remember these formulas. We'll be using them in this video. So the derivative of the basic exponential function b to the x is equal to itself times a little bit of extra. So b to the x times ln b, right? B to the x times ln b. Of course, you can make this a little bit more complicated. Here's one version. So if you take the derivative of e to the rx, so this time the base is e, but in the exponent we have rx, it's basically the same thing with a little bit of extra. So you see you have e to the rx, the derivative of e to the rx is itself times a little bit of extra, but this time that extra is just r. Technically there's an ln e there, but of course ln e is just 1. And finally, the power rule, all right, the first one the first formula for derivative you basically came across. It's simply x to a power is equal to the power times x to the power minus 1. All right, so let's use these in a bunch of examples. Here's one, 2 to the power x plus x squared. So don't get tripped up here. The derivative of 2 to the x is simply 2 to the x times ln 2. And then you add the derivative of x squared, which is going to be 2x. All right, so what was the thing that happened here? The derivative of this whole thing goes like this, derivative of the first thing, and then you add the derivative of the second thing. Okay, so that was easy. So let's do another one. The derivative of 4x to the minus 3 plus 0.35 to the x. All right, looks complicated, but it's not. The first one, you just have to recognize that this is something you use power rule on, and this is something you use the formula for exponential functions on, because the variable here is in the exponent, and on the left part, the variable is in the base. So how does this go? Power rule, negative 12 x to the minus 4, plus itself times ln of the base. Done. Okay, so that's the answer. Another example could be like this, 1 over square root x minus the square root of 2 to the power x. So this time it's not as straightforward to use the power rule or even the exponential rule. It looks a little bit more complicated, so you're going to have to move things around a little bit. How's it going to go? 1 over square root of x, all right, you know that you're going to use power rule there because x is obviously written as a base, even though it's in the denominator. So what should we do? First, we should put it, let's convert the square root of x to a 1/2 power. Since it's in the denominator, since we want to use power rule and x to the 1/2 is in the denominator, let's bring that x to the 1/2 to the top. So it becomes x to the minus 1/2. Okay? And now here we have square root of 2 to the power x. Well, that just looks complicated, but really the base is just square root of 2, and the x is still outside. So that's just square root of 2 to the square root of 2 is the base, okay? And x, the variable, is in the exponent, so we know we're going to use the formula for exponential functions there. Let's just rewrite it so everything is in the same line. So we have square root of 2 to the power x. So we're going to go and take the derivative of all of these things, okay? Remember, it's both of these things together, subtracted. And what do we get? From the power rule here, we get minus 1/2 x to the minus 1/2 minus 1 is minus 3/2 minus, okay, itself times ln of square root of 2. Itself times ln of the base. Okay, if you want, you can simplify that. So let me do that right over here. So you get negative 1/2 x to the minus 3/2 minus square root of 2 to the power x times ln 2 times 1/2. And there you go. All I did was use the log rule that says if an exponent is inside a log, it can come out to the front. Alrighty. And last one, let's take the derivative of e to the negative 4x minus 4x. So I doubt you're going to get tripped up by this one by now. So obviously the function on the right side is super easy. It's just going to be minus 4. The derivative of that is super easy. It's just minus 4. And the derivative of the one on the left, the function on the left, e to the minus 4x, is going to be itself. And remember, the little bit of extra this time is going to be the negative 4, not ln of that. Okay, because the base is e, and in the exponent we have a number times x. And so there you have it. That's the answer. And if you want to simplify it a little bit, of course, you can write it like this with the negative 4 out in front. Negative 4x is still there, and then minus 4. And that's all.